because we have the entire graph of the whole Kaspa. We can, within the moments, find the fact of the connections between any two addresses.
In this episode, Ankit sat down with Alex from KasUnder to discuss their native Kaspa integration.
We put the Kaspa by default and see the graphs of how the transaction flowing in native KAS token across all the addresses. And we have reconstructed the graph from the Genesis block.
KasUnder is like Bubble Map's cooler cousin, initially built for KRC-20 and now with Kaspa Layer 1. KasUnder lights up Kaspa's complex network, making it dead simple to see connections between wallets.
So it has 896 million Kaspa. It also holds a lot of different KRC-20 tokens. You can see the list, it's almost infinite scrolling.
Along with a bonus where Alex found a very interesting behavior exhibited by a specific wallet.
And if you can see on the list of transactions, it does one transaction per minute. Right now, it seems like it is accumulating Kaspa based on some DCA strategy.
Supported by Kaspa.com, the leading Kaspa DeFi with DEX and lending. Igra Labs, atomic programmability on a Kaspa block DAG. Kaspa Finance, the first V3 DeFi protocol on Kaspa.
Today, I'm here with Alex from KasUnder. Welcome, Alex.
Thank you, Ankit. Thanks for having me.
Awesome. Alex, last time we connected was in March this year, so it's been 6 months. When you just launched KasUnder, Kaspa's version of bubble maps for KRC-20. And today I wanted to have you over to discuss your launch of native KAS on KasUnder. So let me start by asking, let's quickly define KasUnder for anyone who hasn't heard of KasUnder.
Yeah, sure. So if to define it quickly, the KasUnder is an analytics tool. Specifically presenting visual representation of relationships between the addresses. So if any addresses make transactions to each other, either in KRC-20 tokens or in Kaspa, we are catching these transactions and we are, let's say, drawing a graph of transactions, and then people can go to the tool and navigate through these routes of how transaction flowing.
Native KAS integration, that's a big step for you guys, right? Initially it was KRC-20. You spent a lot of time really integrating with native KAS. So what does this new native integration, KAS integration, allows user to do? What can a user do with this integration?
Yeah, so now, like as you mentioned before, we had only KRC-20 tokens, and that means like the KRC-20 in general way simpler than, let's say, Kaspa transaction. KRC-20 uses like encryption mechanism, and it's just adding additional information into the Kaspa transaction, saying that I'm doing this operation from this address to that address, and that's all it does basically. And then there is an indexer from Kasplex that accumulating this data into a special database. You can either run your own indexer and replicate the same database state, etc. In Kaspa, it's way more complicated because it uses a different transaction model. It doesn't use, like, let's say, the account model. It uses the UTXO model. I think we'll cover it a bit later. But what it does right now for the user, that users can switch between the KRC-20 and Kaspa, and we put the Kaspa by default, and see the graphs of how the transaction flowing in native KAS token across all the addresses. And we have reconstructed the graph from the Genesis block. So we have all the addresses like created in any time from very first day of Kaspa, and all the connections between them in the tool. It's very hard to get there because you need to click a lot and going through the graph, and you need probably to know where you're going. But theoretically, you can navigate to the first address in the network.
Right. So you had to reconstruct all the way from the Genesis block for Kaspa to till today, right, on the layer 1, and then obviously they are connected to the KRC-20. How long it took for you guys to do that? Like, what was the duration it took to sort of go through this whole process?
So I would say we started it somewhere in June, and like first of all, we are not. It's a pet project for us, so we are not working like full time on this. So it's like just some time when we have time for it. But it took quite a lot of time in general because originally we were struggling on every step, to be honest. So the first step for us was to find actually the database, the Archival database. And there is no publicly available Archival nodes where you can just request, let's say, the whole database. We asked in development Discord of Kaspa, and there are guys who are running Archival nodes and who has these databases stored. And they shared the database. We took the database, and we took the one that has the minimum information, let's say only transactions, because there are like extended one with way more information there, but we were interested only in transactions between addresses. And this database, it was around 600 gigabytes or something, and it had, as I remember, somewhere around 600 million UTXO or something around this. And then we had to go like all the way through all the UTXOs and reconstruct the graph of transactions, let's say, like how they communicate between each other. And the main problem then was that when we write an algorithm, how to do it, we thought it was quite efficient. We ran it and we found out that if we run this algorithm on our hardware, it will take us 2 months to reconstruct it. And the problem, so it's like non-stop running algorithm, just like recreating these connections between the nodes.
Sorry, Alex, I was going to ask you this archival node. So you found someone on Discord who was running this archival node, and then you reached out to them. Do you know how many people actually? I haven't looked at it. Maybe I did in the past, but do you know how many people actually running archival nodes?
How many? I'm not sure. It's definitely more than one, but I have a feeling it's less than 5. So it's not a lot. So just from the, let's say, amount of people who are responding, thanks a lot for these guys who are helped like with this, because it's like some people from who are active in development chat in Discord in Kaspa community. So they're doing like huge work. Like without them, it would be impossible to reconstruct these things at all. Yeah.
Yeah, exactly. I think it's amazing that these people actually maintaining that and keeping the track record of everything that has happened since the beginning, really. So that's fascinating. And the other part that stood out to me is when you said you had to reconstruct 600 million UTXOs.
And somewhere around this number. In the end, we ended up that we just cannot do this locally on our machines. It's impossible, because like the main issue that you can run it for 2 months, and then in 2 months you find that it was an error in the algorithm and you start from the beginning. So from software development perspective, it's not really manageable. So we had to go and order some Apache Spark cluster. Doesn't really matter what that does, but it's like some parallel computing systems. You need to write a specific algorithms for it, like and convert the database in a specific formats. And there are a lot of issues there as well, because like the database that from archival nodes, for example, it do not store the addresses in the string. It stores it in a binary format, because it's just like twice smaller in space. Otherwise, it will be more than terabyte of the space. Yeah. And then for each address, you need to recreate the address, like using some like Kaspa node functions, etc. So yeah, it was like quite a challenge, but in the end, we ended up running it on this super cluster, and within like a couple of hours, it did everything. And so yeah, that was like the happy end of the story for us. But it was quite a challenge and a long way to get there. But we learned a lot.
Yeah.
So
yeah, let's quickly go through the demo. We can see how it looks, and then we can discuss what were the challenges and how you had to overcome some of the challenges, especially around the UTXO model.
Yeah, sure. You can see the tool, right?
Yeah.
Okay. This is a home screen. Yeah, nothing has changed from that perspective. We have right now, the only thing we put like some special signs that it's not a transactions like the Kaspa transactions, it's not the amount of Kaspa addresses. It's all related to the KRC-20 in the widget. So you can see that if there is a million transactions, that's just specifically million transactions the day, KRC-20 on Monday. By default now, you have a Kaspa selected, and this is the bubble map of Kaspa. So that's
I see.
100 addresses from Kaspa and how they connected to each other. As you can see, there are no different clusters, because, for example, in KRC-20, you may find a lot of tokens where there are a lot of different clusters. Here, it's like one huge cluster and then a lot of independent addresses. So it seems like people are using pretty much the same exchanges, because all these intermediate things, it's mostly exchanges. Yeah, so it's like a MEXC, Bybit, Gate.io, etc. So if we can go dive into this, for example, Wallet 3, that recently became Wallet 3. Before it was like a famous Wallet 2. And you can do the same as you can do with the KRC-20 tokens. You just click on Explore Transactions button. So it has 896 million Kaspa, around this number. It also holds a lot of different KRC-20 tokens. You can see the list. So it's almost infinite scrolling. I think just random people sending some tokens there, maybe just to make a connection that, okay, this, for example, I don't know, the Kaspa is held by this second address. But in general, the total amount of all the KRC tokens, it has its $15. So it's like nothing. It's just random people probably sending their tokens just for fun to this address, to connect their address to this address.
Right.
So if we get back to Kaspa, there is some difference with how we present the KRC-20 addresses and the Kaspa addresses. So the first difference that we are not presenting a lot of addresses in the beginning. And the reason for it is that in Kaspa, because of the UTXO model, we can have quite a lot of different addresses connected to each other. And we also do not want to make some groups that are not visible. So theoretically, user can go and load more and more and more connected addresses to the address user choose, and then end up with quite a huge graph. So for example, here, there is a special button like this blue knot, pulsing a bit. And it said click to load more addresses. So when you click it, it will get to load more addresses, and then you can click more and more, and it will load it more. So the way how we load the addresses, they are sorted by the amount of how much Kaspa they are transferred to each other. So for example, if I reload the page, and it will load from the beginning the initial amount of addresses. This is the addresses that have a transfer to the Wallet 3, the most significant amount. Yeah, so when I load the next batch of addresses, this is let's say they transfer a bit smaller, and then smaller, and the last one will transfer some tiny things probably. So that's the way how we can think about it. So when you load the address, you immediately see the most, let's say, impactful addresses to the transaction history.
Can we see who are the biggest wallets sending to the Wallet 3?
So we do not have let's say, the number. We know the number, but we just do not present it here. But I guess it's obviously Gate.io and Bybit. So these two addresses are the most significant from transaction perspective.
Right.
So if I can find any of the transactions, for example, something interesting here. For example, you can see here that all the transactions, they look different than transactions we present in KRC-20. And the reason, because of the UTXO model. And you can see that each transaction has a list of senders, and this is the inputs of the transaction, and list of recipients, and this is the outputs of the transaction. We decided to not call them inputs and outputs just because maybe for people who are not aware of inputs and outputs, it just will be a bit more readable. That's, okay, this is senders, this is recipients. Yeah, but it's literally inputs and outputs in UTXO model. And for example, we can see that there is a 6th of September, and it was a transaction that has 68 inputs and 3 outputs. And then this is the list of inputs. So it's like 285 Kaspa, 284 Kaspa. So like quite a lot of different inputs. And then they went to the 3 outputs. So the first output is the one that actually the new UTXO that got into this wallet 3, 24 million of Kaspa. The second one, it looks like a change. Yeah, so because it gets back to the same address that actually sent this transaction. And the third one looks as, I'm not sure what it might be. It might be anything, but it looks like some fee of 10,000 Kaspa for something. Yeah, that you pay minus like the fee for the transaction that you pay for some service, or I don't know, like maybe somebody, like giving some proxy service for the transactions or whatever. So if you click on the transaction on the UTXO, it's the same how we have it in the KRC-20. You scroll back to the chart and you can see which node is actually sending the Kaspa and to which direction this transaction is going.
So Alex, can I slow you down a little bit?
Yeah. Sure.
How do you define a sender and a recipient?
So in that case, we probably need to go to the details of how the UTXO model works. So sender and recipient list, it's exactly the UTXO, the transaction inputs and outputs. So that's like strongly connected to UTXO model. And what UTXO is, like, it's unspent transaction outputs. So that means that somebody before, somewhere in past, generated the outputs for you, right? So that sent you something, and that generates the outputs that you have on your account. And these outputs still not spent. So these outputs were not used as inputs in some other transaction. And that's what UTXO is. So it's something that you've got, but you haven't spent yet. And you may have quite a lot of UTXO. So for example, with this wallet number 3, when Gate.io or whatever centralized exchange sent this transaction, you may see that it's like 68 UTXO there. So they basically took the 68 past incoming transactions to them, kind of, right? And then send it as, let's say, inputs to the transaction to this wallet number 3. That's in the end created the new UTXO, new unspent transaction output for wallet number 3 with these 24 millions of Kaspa. Together with this, it created another UTXO that probably looks like just a change to the sender, because they wanted to send some specific amount. And if you do not have like the UTXO that when you sum them up, it gets to exactly this amount, that's quite rarely that you will have it. You need to send the change back to the sender. Maybe I will share another screen now and go over 2 small diagrams just to explain like how the address creation mechanism works in Kaspa and how the UTXO works. And then it will, let's say, affect a lot the explanation of how we present this data in KasUnder. Okay, so basically the way how you create the address and let's say the wallet, and I will try to use like a simplified version of the whole thing so that it will be understandable. So first of all, everybody is aware you have your mnemonic phrase. Yeah, this is like either 12 or 24 words that you need to remember, write, and not show anybody. And this is the entrance to your, let's say, wallet. So what happens when you put this, let's say, phrase into some wallet, that this wallet takes this phrase and creates the thing that's called like a master seed. And that's why actually this mnemonic phrase also named the seed phrase, or I don't know, secret phrase, whatever. So I place here some Bitcoin proposals where this originally came from, and Kaspa, from the perspective of wallet management and UTXO, literally implementing the same approach that Bitcoin does. So if you want to learn, if anybody wants to learn how things works, like from the wallet creation and UTXO in Kaspa, you can find quite a lot of detailed materials about Bitcoin, and in Kaspa it will be like identical or almost identical.
Yeah.
So from the seed phrase, there is a wallet created, like it's called HD wallet. And the main thing of this wallet that it allows you to create a master private key and master public key. But what you can do then, you can create multiple accounts from this. And under multiple accounts, you can create multiple addresses. And there is no really limit for it. So for example, you can create account, and then you can create like, by default, it will create you some receive address. That's the address where the one that you will give to somebody who wants to send you tokens. When there is a transaction happens, what most of the wallets do, okay, maybe not most of the wallets, but some of the wallets do this, they automatically create a new change address. So for example, when you make a transaction, if you have a change, then this change will go not back to your original address that you from which you make the transaction, but it will be automatically created another address, and the change will get to that address. And this UTXO that will be created by this mechanism will be seated, let's say, on this change address. And next time you make a transaction using this change UTXO, you will have, let's say, 2 UTXO, or maybe 3 or 5 or whatever, and they might be completely from different addresses, although they all belong to your account. So these change addresses, like based on the wallet, for example, as far as I know, like a Caspian wallet creates change address automatically for each transaction and receive address automatically for each transaction. So every time you're, let's say, receiving your Kaspa new address, and you get changed to the new address. And all this thing works quite well for your privacy. Yeah, so if you don't want anybody to understand like what's your accumulated amount of Kaspa on many addresses, if wallet supported, yeah, you can do it. So there is no limit, at least like visible limit, let's say, for how many addresses and how many accounts you can, let's say, handle like this. And that's one of the specific thing that you need to be aware when you're navigating through the graphs of transactions and when you're checking the transaction. Although the addresses in the senders and recipients might be completely different, these addresses might belong to one single account, for example, or one single wallet.
Right. But so essentially what you're showing us with the master private key and the master public key, this wallet can actually create accounts and can have multiple accounts linked to the same private key.
It's created another, let's say, sub-private key that generated from this private key. So you can recreate the whole thing. Like if you know your mnemonic phrase, you can recreate, like not you, like the wallet, can recreate the whole thing all the way down. And like all the accounts and all the addresses, and then calculate how much you have on all the addresses, and that will be your, let's say, overall wallet balance. Yeah,
right.
That's how it may work.
Yes. So far we really talked about the wallet management here.
Yes, I will show in a bit why this matters, because like this wallet management is actually quite coupled to the UTXO and to the fact how it makes things more complicated. So here I have this second diagram where we have some, let's say, real world example. We have Alice, we have Bob, and Alice wants to send Bob 30 Kaspa. Yeah, so like, and we will quickly go through what is happening during this process. So for example, let's say Alice already got from somewhere in past 10 Kaspa, like this is specific, like a Coinbase transaction. So Alice has her own miner, for example, and this is the mining reward. And somebody else sent 25 Kaspa to Alice. So what in the end this does, that on Alice wallet, we have right now 2 UTXO. So it's like 2 unspent transaction outputs. Yeah, whenever you get something that's becoming unspent transaction output. So it's like a transaction output from another transaction that you haven't spent yet. So we have 2 of them. Like one is 10 Kaspa, another is 25 Kaspa. And we want to send to both 30 Kaspa. So we create a transaction. Yeah, this is transaction that has inputs and outputs. In KasUnder, we name these inputs senders and outputs recipients. And the inputs originally, you need to put as many as UTXO that like in some of them will be more than the amount that you want to send or equal. So in our case, we cannot just take only 25 Kaspa UTXO or only 10 UTXO. We also cannot here just decouple them or like cut the half or and send the half of it. So the UTXO, it's like, let's say you can think about it as a coin. Yeah, you have two coins here. One is 10 Kaspa, another one 25 Kaspa, and you can pay just like with these two. But when transaction happens, transaction generates the output UTXO.
Yeah.
Yeah.
Alex, I was going to say, I think that example is a perfect example because if you were sending from Alice to Bob 20 KAS, right? If you wanted to just send 20 KAS, well, in that case, it will just take the one UTXO entry of 25, right? It will not need to take both of the UTXO entries.
Yeah, theoretically you can, but
yes.
In practice, it depends on how the wallet implements this. So the wallet can still take both of them and get the, let's say, some sort of exchange, right? So there is also, maybe we also can briefly cover it, there is a compound of UTXO, and what compound is like when you have a lot of UTXO and spend transaction outputs, it might be an issue for the transaction because the transaction getting bigger. You need to put many UTXO there. So each UTXO, it's like additional data. As more data you put into the transaction, as more, let's say, bigger transaction is, and it increases the transaction mass. And then you get, let's say, penalized by the paying higher fee for the transaction if the mass is high. And if it's like too high, you might not even be able to make a transaction. And to avoid this, you need like, let's say, less UTXO than just having more points on it, right? So instead of, let's say, 10 and 25, let's say you want to have one UTXO, but that will have 35 Kaspa. So you can take these two UTXO and send it to yourself with amount of 35 Kaspa. And then in the end, it will create an output with 135 Kaspa UTXO, like 35 minus the transaction fee. And that's the what compound is. So you just consolidating your UTXO in one.
If you're new to UTXO, I think it's a beautiful way to learn because you can see actually what's happening here with a little bit of high-level discussion also. And it obviously leads to how KasUnder had to resolve the issue on their side, which we'll get to in a second.
Yeah. So on KasUnder, what happens when such transaction created is actually we take this transaction, we take the inputs and outputs, and we connect them basically like this. So if they are, because these UTXO, they might belong to different addresses. Because these Alice, as I showed here, might have, let's say, 2 recipient addresses. And the Coinbase transaction went to one recipient address, but this 25 KAS transaction went to another recipient address. So the UTXO in the end might belong to different addresses. But when Alice make a transaction, this UTXO goes to one transaction, and this transaction is like from one address, this from another address. So in fact, like we cannot know which of the, let's say, Alice addresses like is a main address, or even if the main address exists in general. Yeah, it's just a virtual term, the main address. So that's why we are connecting, let's say we are making a connection on the graph between all the inputs in the transaction to all the outputs of the transaction.
Wait, but you still know it's Alice's wallet, right?
Theoretically, yes. This is like Alice's wallet. So if we want to consolidate let's say some sort of a account of Alice, we might say that, okay, these two wallets are related to one, not wallets, these two addresses are related to one Alice wallet.
Main wallet, right? You would call it primary wallet or something like that.
Yeah, whatever. But in reality, even if you are making automatically extremely a lot of wallets, right? And you send like a small amounts everywhere, in the end, you will still get into the need of compound the UTXOs because it will be too many UTXOs, like it will be not really manageable. You will need to compound. And the best way probably how to catch the wallets in on the moment of compound. Yeah, because like when you aggregate the UTXO from many wallets and send it to one. And many transactions that, for example, you can see even on this address 3, okay, not many transactions, but if you see that transaction is not going from the exchange, but it goes from some random wallets, it might not be actually the transaction where somebody is sending funds to this wallet 3. It might be just a compound transaction from the wallet 3 holder.
I see.
In the end, just to finish in this picture, we end up that we no longer have this UTXO on the Alice side, right? And we have a new UTXO on the Bob side. So this is unspent transaction output from Bob. So this is an output from transaction that Bob hasn't spent yet. Yeah, that's why it's named unspent transaction output.
Of course, yeah.
For 30 Kaspa. And then we have a change that actually, because like here, 25 plus 10 is 35. So, and Bob needs only 30. So we need to return back the change. And for the change, as I mentioned here, many wallets are created automatically new change address. So this change might not even go to one of these addresses, but it might go to completely different address. Yeah. Of Alice. And that creates another UTXO.
UTXO.
Yeah.
Why don't we jump back on KasUnder now to connect those two things together?
Yeah, sure. And I will also show it an example of another address that I found just randomly quite interesting. So let me know if you see my screen now.
Yes, I can see a screen. Sorry, Alex, before you jump on that random address you found, some interesting bits for us. Can you please go back to the screen of sender and recipient just to finish off that thought? Oh yeah, just
yes. So you have 49 inputs so this is individual transaction, one single transaction, right? And you have 49 inputs in this transaction. So that means that each input here, each sender, how we call it, it's a UTXO. It was a UTXO before this transaction happened. So it was a unspent transaction output of another transaction in past. And then they use these transaction outputs as an input. So they literally kind of sending these inputs now into another wallet, and using like having two outputs here.
Yeah. I see. So combining all that UTXO entries to send it to someone else.
And you can see, this is interesting example actually randomly found. So you can see how most likely they're doing UTXO compounding together with the transaction at the same time. Because you see that on the address that they sent, they willing to send these amounts, they got only 13.9 Kaspa, right? And then they get back to 100.
Yes.
So, but to send 13, you don't need so many UTXO, right? So you could end up with like how many, like 3 of them or 4 maximum. So it's like automatic compounding your UTXO. So in the end, they end up that they sent 13.9 to the recipient, right? And they send back one single UTXO with 200 Kaspa. So instead of this huge amount of UTXOs, they now have just one single UTXO that they can use in the next transaction.
Yeah. So that's done by the wallet management, and perhaps different wallets handle UTXO differently.
Either wallet management or some handwritten system that manages some behavior of the bot or whatever. So like Kaspa SDK provides all the possible things to do such stuff.
Very good example, perhaps, to see how the compounding works. Is there any way to consolidate all of these UTXOs and simplify it? I mean, it's good to see that the complexity behind it, but is there any way to abstract away this complexity for the user?
I think so, but there is a drawback of this approach because, for example, even if we are considering that we had this a lot of UTXOs, right? And they may come from completely different addresses in one single transaction, and they may go to different addresses. So you might specify, 20 addresses that you send the money to. For us, it's almost impossible, not almost, it is impossible to understand, let's imagine that these 49 UTXO, let's imagine they all come from different addresses. So it's not one single address. Let's say each UTXO has its own individual address. And as I showed before, like we have 49 addresses that have the UTXO, controlled by one wallet, and then you spend them in the transaction.
Mm-hmm.
And let's say the recipients is not one address, but let's say 5 addresses, right? So we do not really have a ability now to connect like how many of these UTXOs, like how many, let's say, accumulative amount of these 3 wallets spent to the first address, and that accumulative amount of that 3 wallets went to the second one. Because we see just all inputs and all outputs. We can just approximately guess that, and that's actually what we are doing behind the scene.
Mm-hmm.
We are kind of approximating all the inputs into all the outputs and saying that, okay, we are guessing that they're spreading respectfully to all the addresses, and all the senders get, let's say, the spread of these inputs. So theoretically, we can accumulate, like somehow aggregate all these inputs and then store on the database level that if we see that there are 49 different addresses in one single transaction, there is like a huge probability that this is one single wallet, where it's like controlled by the one single, let's say, master private key. So this is possible to do, but how they will be connected and what are the amounts they're sending to the recipients, this we can just guess.
Yes. And perhaps another way you could do is if you run your own nodes and create something like account-based, like a snapshot of the wallets, and then you create an account yourself.
Yeah, we can do it as well. So the thing is, for example, our graph representation, so this is just a graph representation that has like all the addresses created in Kaspa for the whole history, and all the amounts that sent between these addresses, like considering this approximation that I just mentioned. So this database takes around like 40 gigabytes with just this information. So if we would go to, let's say, making all these assumptions about accounts, I think it would grow such significantly that for us it would just like too expensive to manage. Yeah. So even already with the data we have, because for example, what the data we have allows us to do, because we have the entire graph of the whole Kaspa right now, we can within the moments find the fact of the connections between any 2 addresses in Kaspa. So we can say that, okay, if this address has any connection to that address through, I don't know, 5 nodes, 10 nodes, whatever nodes, and we can draw these, let's say, connections. Right. We can also count all the miners, because we know all the Coinbase transactions. So we can mark all the miner addresses as well. So that's already what we can do. And as you mentioned, like there are huge potential. What else can be done here? We just not really sure what will be needed in the future, to be honest.
Yeah. No, I understand the challenge, and I think it's it is a challenge, especially when you are creating this product as a sort of open source for everyone, right? It's not a commercial product for you. Perhaps that's what I'm trying to say. So, one thing you just mentioned, there's an example of wallet you found that has a very unique pattern. Can we look at that wallet?
Yeah, it's actually this wallet that I'm showing right now on the screen. So I will try to bring more addresses just to draw some picture for the graph. So I just loading more and more addresses, let's say less impactful into the how many transactions they made. But already we'll see some pattern here. First of all, what is interesting about this wallet, that this is a bot. This is not a human wallet, it's a bot. And if you can see on the list of transactions, like the way it does transactions, it does 1 transaction per minute. And it does it without any breaks, so just 1 transaction per minute. So it's 233, 234, 231, etc. So it's always 1 transaction per minute. And all these transactions, they are, let's say, if we click on if we see that this is a receive transaction, so it's getting funds from this address, and this will be also receive transaction, so it's getting funds from exactly the same address. This is exactly the same address, and you can see that they're compounding every time in this transaction. So they are sending exactly the same amount, they are getting change back in exactly the same amount back with 200 UTXO. And when I went, let's say, all the way back to the history, this address is doing it. I think it's some sort of a trading bot or something. And right now, it seems like it is accumulating Kaspa based on some DCA strategy. But there is like periods of time when it's actually selling it exactly with the same pattern. So it's like one time per minute, it just sent the Kaspa somewhere else. And it happens, for example, for 2 weeks, and then it's for 2 weeks accumulating Kaspa, then it's sending Kaspa. But if you take a look on this wallet in kas.fi, for example, where they have a chart of how the balance is growing, like the balance is going up. So in the end, it's like, it looks like it has some profit.
So this wallet is constantly selling it or sending it to someone else?
It's sending it to a lot of proxy wallets. We will not be able to load all the graphs. I think it's like thousands of wallets, that because like it's bot created, so it's not a human who is doing it. But you can see even the patterns from the neighbor addresses. So for example, here there are a lot of independent addresses where this wallet sending things. So you can see when I zoom it in, it's like a lot of lines that go in.
Holy shit. Okay, yes, I can see.
Outside of the wallet. And that's how you actually can visually catch, is the wallet accumulating more or it's sending like more? Because when you zoom it in, when you load many addresses and you zoom it in, you immediately see if it's like too many lines that going out or too many lines that going in. And for example, here, we can see that there is like another wallet that communicates to this wallet. So it's the only wallet that this wallet sending transferring tokens there and back and getting it back. So there is a solid line between them. Yeah, it's like it's both direction communication.
Yeah.
And this wallet also send the wallets to the Kaspa to another wallets that this is sending there. So it's like a huge amount of proxy wallets that is spreading the Kaspa through entire this net of the wallets. And then if we go somewhere back, then we will see that some of the wallets just start to send it to CoinEx exchange, or getting them from MEXC or CoinEx or etc. So in the end, it still goes to the centralized exchanges.
Yeah, it's a really weird behavior. So it's sending it to somewhere else. Every minute it sends it to a different wallet.
All these lines, they are
going out
one direction. Yeah, so they're not sending, for example, if I will take this wallet, you see that this line is going directly to this wallet, together as this line is going to this wallet. So if I go to this wallet, just zoom it in, zoom it out a bit. Yeah, we see this, the original one. And here you can see it's like a clear, another proxy wallet. So you see a lot of wallets are sending to this wallet, and that wallet spreading it to another wallet.
That's
that
crazy.
Also spreading it to this wallet. So for example, here you can see that these many wallets sent to this Z9E, and all of them sending. So if we jump here, it will be another accumulation wallet, and you can see that everything is going here except one that going out. So we going deeper, then we going deeper, and then we found something with 500,000 Kaspa. Yeah, that's, for example, already not a proxy wallet. That's something. Sorry, no, it's not 500,000. No, it's 500,000.
Yes, 500,000,
yes, 500,000. Yeah.
So if you were to speculate it, what do you think this wallet is doing? It doesn't look like an exchange. What do you think this could be? This is very fascinating to see the behavior, the weird behavior.
I'm not sure, to be honest, but I would guess that this is like, because other wallets where this one is sending, they also have a lot of like KRC-20 tokens transactions So I might guess that it's some trading bot that trades, maybe try to like a Kaspa, KRC-20 on different exchanges with some, I don't know, like or just some investment bot or whatever, something like this. Because otherwise, I cannot imagine why would you every minute like send the same amount or like get it back. So
perhaps one for the community to look at. Maybe if you want to share with us this wallet, we can put it there if people wanted to have a look and play with this wallet themselves. If in case they find some unique patterns, they can share with us. That will be a good fun for everyone to play around with the KasUnder. So that's cool, Alex. Anything else on the platform that we can look at?
I would say nothing significant. The only thing, we added the Kaspa to the list of transactions as well. But it's very similar to what we just seen. You put the address and you see a list of transactions and you can go back and forth. So there is nothing special here, except there is nothing new from functionality.
Oh, I have a question then. I know a wallet that holds KRC-20 tokens. Is there any way for me to go back to look at how much Kaspa that wallet hold?
Yeah, sure. So for example, we can here switch to the KRC-20, all the tokens. So it shows the bubble map of all the tokens. I think, so this is, okay, this will be probably Zelos or whatever wallet. We can check what it holds. So you switch here to KRC-20 and it's like, yeah, it's probably the Zelos swap wallet. If I switch here to Kaspa, you see how much Kaspa it holds. It holds like 1.25 million of Kaspa. And if I go to explore the transactions, so it's exactly the same approach. If you are in all the KRC-20 tokens, you see here the all the KRC-20 transactions. If I switch specifically to Zeal, for example, I will see only Zeal transactions from this wallet to the neighbor wallets. If I switch to Kaspa, I will see only Kaspa transactions to the neighbors.
I see.
And that's not a lot. So it's like, that's all the Kaspa transactions happens on this wallet. And then you can go through, for example, I can go here and I can do exactly the same exercise. So for example, here there is no KRC-20 tokens. And if I switch to the KRC-20 transaction, you see that there is nothing here. And since we have the whole history, that means that this wallet never had any KRC-20 transaction at all.
I see.
Because like if you're let's say investigating something, or if you're just curious about some transaction flows in KRC-20, you ending up with an address that didn't have any KRC-20 transaction, but this address got a Kaspa from somewhere. For example, some address that minted something, or some address that deployed some token. But where this address actually took the Kaspa from, that also might be interesting. And then switching to Kaspa and then following the Kaspa transaction flow, you might end up that it connected to another address that might deploy other tokens or something like this. So it's just another layer of, let's say, visibility and transparency from that perspective. Just keeping in mind that complexity that I mentioned before with the UTXO model and all this kind of stuff.
Right. Oh, awesome. Like, thank you, Alex, for sharing the demo with us. I do have a wrap-up question for you, which might be a bit spicy. What is your plan for the upcoming layer 2s?
Yeah, so I probably will have to answer a bit longer. Originally, we had a plan to extend the graph capabilities to the layer 2. And I had, to be honest, quite a different understanding of what layer 2s will do compared to what they have right now. Because in my understanding, there are two main, let's say, preconditions for me for the layer 2. Like the first one, it shouldn't, like the lockup time should be as minimum as possible. So I shouldn't just lock my KRC-20 tokens or Kaspa on layer 2 that's quite centralized. Let's be honest, it's not decentralized as Kaspa is, right?
You mean bridge? You specifically mean bridges, right? Not the layer 2s.
Yeah, it doesn't matter. So if I bridge them, that means that it locked on the, let's say, bridge account on layer 1 on address, and then I kind of have them on the layer 2. And so one of the assumptions I had that the guys who are developing the layer 2, they will put as much attention on the bridging as possible. And especially to make this programmatically available for the users, like to quickly go to the, quickly move your asset to the layer 2, let's say make a swap on the DEX and move it back. And for me, that was kind of expected behavior. Yeah. Because like, as we know, the layer 2 for Kaspa, it's not the same as the layer 2 for Ethereum. Like Kaspa doesn't have this problem with the scaling the throughput. That works quite well. Kaspa doesn't have like Turing complete smart contracts capabilities. Like, and the scripting is not Turing complete. So and as I understand the vision of Jonathan, Michael Sutton mentioned it, that they intentionally do not want to bring it on the layer 1 because it's it gets with a lot of circumstances that they don't want to face, right? So and in my understanding, the layers 2 will be this proxy way going towards this idea. What we have right now that unfortunately nobody was caring about the bridging at all. And I'm not even talking about the fact that you cannot like within the seconds bridge it there and back and make a transaction. And I totally understand that the bridges that we may have, they will be like fully centralized. And I don't have any issue with this because in my opinion, the layer 2 we have, they also fully centralized. So it's up to the people either they want to use it or not. But the fact that this kind of a bridging mechanism is not provided, for me, just like reducing a lot the sense of using layers 2 like at all. So I do not see any, like a significant case where maybe some companies or anybody else will go and use the layer 2 in the way how they, let's say, construct it right now. And one of the main reasons is the lack of the bridges. So whenever some automatic bridges, let's say, or more advanced bridges mechanisms will come, we also will jump on this topic. But for now, we don't have a plan.